So does that mean that their sides are going to be equal? No. What's the word that we use to describe the sides of similar triangles? Starts with a P. Proportional, yes. So the sides are proportional, which means they're not equal, but it means that they have the same ratio. But it does mean that the angles are congruent. So here's our symbol for similarity. But a lot of the stuff we do is very similar to congruent triangles. So for example, angle R, what does angle R match up with based on my similarity statement? Yeah, angle M. Okay, so R and M are the same. And I've got angle Q. What does Q match up with? L. And we know that the vertical angles would be congruent here. Okay, so this is going to help me out. What side matches up with 30? 40. 40 and 30 go together. 30 is between the angle with 1 tick mark and 3 tick marks. So I would do 30 over 40. And so notice that's a small triangle over big triangle, because 30 is smaller than 40. So what would go on top here? What side would go on top of the next fraction? 27. Right, because that's from the small triangle. And then what is the corresponding side on the big triangle? X, or the question mark, yeah. So here is the proportion that I would be solving here. 30 over 40 equals 27 over x. And how do we solve proportions? I think I heard it. Yeah, we're going to cross multiply. One thing that can be helpful when you cross multiply is to simplify the fraction first. What does 30 over 40 simplify to? 3 over 4, right? The zeros cancel out, they both divide by 10. So this can make the math a little bit easier. So when we cross multiply, we do 3 times x equals 4 times 27, which I don't know what that is, but I do know that 27 divided by 3 is 9, so this would be 4 times 9 would be 36. We can use a calculator for that as well. Okay, so we're setting up a proportion based on the similarity statement, and then we're going to cross multiply. That's our process. Okay, so for number 2, if I want to go small triangle over big triangle, what's a number that I could start with in my proportion? Huh? Number 2. I want to do small over big. So what's a number I can start with? Okay, I can start with 8. And you're saying 8 goes with 24? How do we know 8 goes with 24? I didn't quite hear the answer, but the angles match. Okay, so G goes with U, and we see that H and T go together. Yes, so we can see that 8 and 24 match. So 8 over 24 would equal, what's that?
5 over x.
5 over x. Yeah, we want to go small over big. Again, we can simplify that fraction right there. What is 8 over 24? 1/3. Yeah, we cross multiply. X times 1 is x. 3 times 5 is 15, so x just equals 15. Okay. Questions on either of those? Okay. Let's take a look at number 3 together, because number 3 is a little. The process is similar, but there's some new things going on. Okay, so in similar triangles, what is true about the angles? They're congruent. Okay, so I'm noticing here that y is an angle, and we also have other angles. But then I'm also noticing that we have sides. So 3x plus 2 is a side, 5x minus 2 is a side. All these are sides. So we have angles and sides in this problem. So angles are congruent, sides are what? Proportional. What do we want to do first, angles or sides? Angles? Okay. So angles, I see 35 right here goes with angle H. What angle goes with angle H? Angle L. So that means that this one here is 35 degrees. Because H and L go together. Now, I could keep matching the angles between the triangles if I want, or is there an equation that I could set up right now that would help me solve for y? What is it, Abby?
2y plus 6 plus 35 plus 95 equals 180.
Yes. So we have 3 angles. We're going to add them up to 180. We've done this a lot. 35 plus 95 is 130. And if you guys have a calculator, you can probably do this a little faster than me here. Maybe. So we add them to 180, combine like terms. And so. So that's the exact same process that we would do if the triangles were congruent. We know that the angles are congruent, so we can match them up. Okay, sides are proportional, which means that I'm going to need a proportion. So I want to know what side 3x minus 2 goes with. 3x minus 2 is between f and g. That goes with JK? Okay. So yeah, F goes with J. And K goes with Q. So I could put 3x plus 2 over KJ, which is 5x minus 2. Because those two sides go together. And then I just need to match that with 2 other sides that go together. And notice I'm doing small over big again. What's going to be on my other side of the equal sign here? Would it be right to say 5 over 10? Would that work? Okay, you guys are shaking your head. Why?
Over
10 over 14? Okay. Why is 5 over 10 not work? They're on the same triangle, right? Yeah, we need one on 2 different triangles. So, small or big, 10 over 14. Does that work? This is fine. Okay, 10 is between H and F, the 1 angle and the 2 angle. Over here we have the 1 angle and the 2 angle. That's 14. What does 10 over 14 simplify to? 5 over 7. Okay, so we might notice also that 5 and 7 are 2 options. Either way, we're going to get to 5 over 7 equals 3x plus 2 over 5x minus 2. When I cross multiply right here, what is that going to equal? 25x minus 10. Yes, we're going to have to distribute that 5. So if I want to do a middle step that looks like that, that's fine. And then what would the other side equal? Yes. Okay. And so now we just solve. So I subtract 21x from both sides. And add 10 to both sides. So I get 4x equals 24. And x equals 6. Okay, questions on that process? Let's go on to the next page. Okay. So we're going to talk about proving triangles are similar. And there are 3 ways. We have angle-angle similarity, which says if 2 angles of one triangle are congruent to 2 angles of another, then the triangles are similar. And so what that could look like is if I have 60 degrees and 40 degrees right there, and this one is also 60 and 40 degrees. Zoom in a little bit here. Okay, so we only need 2 angles because for both of these, we know what the third angle would equal. What would the third angle be for both of these triangles if they have a 60 and a 40 in there? It would be 80, right? Because we add 60 plus 40 is 100. And there's 80 more degrees. So we know for both of them, the missing angle is 80 degrees. We can write it in there if we want. But we know now that all three angles are the same. So if you have two triangles with two angles the same, we know the third angle has to be the same because the total for both must be 180. Remember, for congruent triangles, that angle did not work. For similar triangles, it does work. Because we're not trying to show that they're the exact same, we're trying to show that they are similar. We also have side-side-side similarity. Which just says if, we should really say if all three pairs of corresponding sides of two triangles are proportional. Then the triangles are similar. And remember that proportional means they have the same ratio. And it's really important that we check all three pairs of sides. So let's say this triangle here on the right had sides of length 2, 3, and 4. And we saw another triangle that was 4, 6, and 7. Are these triangles similar? No, they're not. The ratio between them matches a little bit. 2 to 4 is the same as 3 to 6, but it's not the same as 4 to 7. What would we need to change that 7 to? Yeah, we would need to make that 8. And now the triangles are similar. And we could show that as 2 over 4 equals 3 over 6, which equals 4 over 8. Showing that all pairs of sides are the same. Okay. Then we have side angle side similarity. It says if an angle lengths of the sides. I wonder what exactly phrase we want to put in there. This is not how I would have worded it, but that's okay. If one angle of a triangle is congruent to an angle of a second and the lengths of the sides adjacent to the angle. I would have said two sides and the included angle is how I would have said it. Then the triangles are similar. So what that could look like is we have X and M congruent. And then we have something like this. We have, let's say 5. Let me do 5 and 7. Let me do like 6 and 8. And this one is 3 and 4. Here's a question. What about this? Would these two triangles be similar? Yes, they would. They're similar. Because 3 doesn't match up with 8. What does 3 match up with? 6. Why would we choose 6 instead of 8? Because they match. So here's what we would be looking at. We have side angle side, and of 6 and 8, which side is smaller? 6. And so when we're looking over here at side angle side, which side is smaller? 3. So we're going to match the shorter side with the shorter side, and the longer side with the longer side. And then we see, oh, even though the order is different, it's like the triangle's just turned around. So this would be an example of side angle side. Okay. So we're going to look at some other examples. This one here that says examples of angle, I'm going to change this to examples that could be angle. Not all of them are. For number 1 here, are these two triangles similar by angle? No, because the angles are different. So we'll say no for that one. What about number 2? Yes. So we have 2 angles. I want to look at number 5 with you guys, and then let you go. Do the rest. So number 5, we have 2 triangles here. We have a small right triangle there, and we have a larger right triangle here. Are these triangles similar by angle? Why? Yes. These 2 triangles overlap right there. They have a shared angle. So the answer for this one is yes. So notice what I did is I separated the triangles. I drew 2 different drawings. And this here is a shared angle. Okay. We'll take a couple minutes. Do the rest of these. You're just saying yes or no. Are they similar for angle or not? Okay. Number 3, yes or no? No. Yeah, those angles don't match. We should find the missing angle. That's always helpful just in case. The missing angle, they still don't match. Okay. Number 4, is this angle? Yes. Where's the other angle come from? The vertical angles. Okay. Number 6, is this angle? Yes. Where's the other angle come from? It's an isosceles triangle, yes, which means 2 legs the same, 2 angles the same on both of these. Remember, 2 sides the same means 2 angles the same. Okay, so number 7, we have this triangle here and this triangle here. So they're overlapping. Are they similar by angle? Yes. They have a shared angle here at the top. And then we also have corresponding angles because of the parallel line. So there's 2 right there. We could also use these corresponding angles right there. If I draw these separately, that's not very good. We'd have 1 at the top, 2 here, 3 there, and the black triangle like this. Okay. This one here, there's 3 triangles. We have a blue triangle, we have a red triangle, and then we also have this larger green triangle. Okay, are any of these triangles similar by angle? No? So, I'm not sure the answer to this, but what is the angle at the top equal for the blue triangle? That's 84. What would the angle at the top equal? Six, right? 84, 6. In the red triangle here, is that a right angle? No, it's not a right angle. Okay, so red triangle is not similar. And then green triangle, we should check if that's 32. Okay, well, it's not going to be 84 or 6, right? So yeah, this one is no. But we do need to check all the angles. Okay, here in number 9, again, these are supposed to be vertical angles here, which means I have 50 on both sides. Are these triangles similar? Awesome. Yes, why?
Because there's 2 angles.
Sorry, can you speak up?
The vertical angles and the corners.
Okay, yes, so if you find this missing angle right there at the top, what does that equal?
That equals 8.
Yeah, that is 84. And then this one equals 46. Yes, so when we find the missing angles, we do see that actually they are all the same. So that one's going to be yes. Nice. Questions on any of those? Okay, we'll look at some examples of side, side, side. So remember, we have to look and see if the ratio is the same between all 3 triangles, all 3 sides, sorry. So in number 10, notice we have the sides 4, 7, and 6. 4 is the smallest side, 6 is the medium side, 7 is the largest side. Over here on this smaller triangle, we have 2, 3, and 3.5. So we just want to pay attention to what's biggest and what's smallest in those groups there. This is telling us to do small over big. So if I put down 2 first, what side matches with 2? 4, right? Because those are both the smallest sides of the triangle that we have. Then I would go 3 matches with 6, yeah, because that's the medium side. And then 3.5 with 7. Okay. Do all of those ratios equal each other? Yes. What do they all simplify to? 1/2. Yes. So we would say yes, they are similar. Okay, what do we think of number 11? Are they similar? I heard some no's and I heard an answer. I saw some say yes. Side, side, side. Yeah, we don't have any numbers, so this one's kind of tough. But what type of triangles are these? Yeah, they're equilateral triangles. Yes, so all the angles are 60. So actually, this is not really a great example of side, side, side. It is a good example of angle, angle. They are similar. I would say by angle. All equilateral triangles are similar. Okay, you guys do numbers 12 and 13. Number 12. Again, it says small to big right here. So if I start with 4, what would we try and match with 4? 5. Yeah, we're picking the smallest side for both. Then I would go medium. So 8 goes with 10, and then 12 and 15. Okay, are all these ratios equal? Yeah, what do they all simplify to? Yeah, they all equal 4 over 5, so we would say yes, these are similar. For number 13, so we'll go small to big again. So 6 matches with 6. Yeah, that's the two smallest sides. And then 9 matches with 10. Okay, so already, are these triangles similar? No. Okay. Well, we don't need to keep going. We could, but those are not equal. And it doesn't, 12 over 14 is not equal either. Okay. Let's go to the next page. Okay, so side angle side, it's kind of a combination of those. In number 16, where is the angle that they might both have, or would both have?
The top.
Yeah, the top one here. Okay, I can't say that those two are the same because I don't know if these lines are parallel. So I'm looking at this triangle here. I really recommend drawing these triangles separately. Between the triangles, it's not 1 to 3. It's 1 to 4. So on the big triangle, what are the side lengths? 12 and 15, no.
20, 18.
18, 21?
16.
16 and 20, yes. Okay, so if we're looking at this big triangle here, the sides are not 12 and 15, the sides are 16 and 20, so we have to add those lengths together. Yeah. Now, one thing we're going to learn soon is that if we see this same ratio between these two, that does mean the lines are parallel. But if we're talking about the ratio between the triangles, the ratio between the triangles is 1 to 4. Because if we go 4 with 16 and 5 with 20. So we just want to be careful. We should also check right here and make sure that we're agreeing with the statement that they said. So they said RST. This one is RST. Matching with PSQ. Okay, yes. A good trick question would be if they scrambled the order of these, so just make sure we look and they match with what we're looking at. For number 17, where would the angle come from? For side angle side. Where did the angle come from for number 17? The vertical angles right here. Okay. So we have our vertical angles, and then if I'm going small to big, what matches with 2 as a side? 8. And then what would the other ratio be? 3 to 12. Okay. Are those things equal? Yeah, they both simplify to 1 over 4. Yes. So this would also be side equal side. So it's really important to match the sides correctly. Okay. We're going to go to the next page. We're going to skip that bottom section right there. And we'll look at some of these together. Okay. So for number 1, this could be side angle side, because we have an angle here and there, and we have some sides. So what matches up with 5? 8, and then we would have 7.5 with 12. Without a calculator, I don't really know if these are the same. So someone in the calculator do 5 divided by 8. What does that equal as a decimal? Who's got a calculator? 5 divided by 8. What does that equal? Rachel? 0.625. Okay. And what does 7.5 divided by 12 equal? All right, 0.625. Okay, so are these triangles similar? Yes. Okay. In number 2, I see a 5 as a side length. I see some angles in there. What's something that we should do to help solve this problem here? What would be some good other information to find? Figure out the missing angles. Yes, we want to know what that equals, and we want to know what that equals. Well, actually, we really just need to find one of them. So if we do that 180 minus 125 minus 27, what does that equal? (180 minus 125 minus 27)? 28? Okay. Are these triangles similar? Yes. Are they more than similar? What are they? Yeah. These triangles are congruent. These triangles are congruent by angle side angle. So there's a little bonus. We would say the ratio between the sides is 1 to 1 to say that they're the same. Yeah, I don't know what's up with these numbers here, but those are the side lengths, so I'm going to write them in a way that makes more sense. Turn to your partner, are these triangles similar? Okay, so I'm hearing a lot of people say yes, why, yes. Side, 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 how do we know? Okay. The ratio is 1 to 2. Yeah, so 11 over 22 is the same as what? Huh? Yeah, but I need to show all three sides.
20 over 40, 21 over 40.
Okay, yes, so 20 over 40, 21 over 42, yes. So we do need to show the work. But yes, this is side, side, side. Are these triangles congruent? Yes? No? Jackson, what does congruent mean?
Equal.
Equal. Okay, are these triangles equal? Do they have the same side lengths? No, yeah, they're proportional, right? But one is twice as big as the other one, so they're not congruent. Okay. Number 4, what do we think? Are they similar? Yeah? Are they more than similar? They're congruent, yeah. They're congruent by what? Side, side, side. Okay, so all congruent triangles are similar. But not all similar triangles are congruent. So if two things are exactly the same, then that means they are similar. They would have a ratio of 1 to 1. So, okay, number 5. Jackson saying no?
Yeah.
Why?
What did I say? Because I just don't think they could fit together. I looked at it. I don't have a calculator, but my eyes say no.
Your eyes say no. What do you think? Is he right, Megan? Okay. Yes, Jackson. Okay, Jackson. Okay. Yes. Jackson was correct. Megan had a better explanation. No offense. But no matter what this angle equals, we have a 39 right here, and that's a 37, and that's a 15. So 39 does not match either one of those angles. And there's no way that this missing angle is, there's no way the angles match. So we could say they're not similar. We could say the angles are not congruent or they don't match. We don't need to even check the sides. The angles are so jacked up. You knew it in your heart of hearts. Okay. Turn to your partner and do number 6. Yes or no? What do you think, Omar? You think yes? Why? You don't know? Okay. What do we think? We can explain how to do this. Yeah, what do you got? Okay. So wait, so you found this missing angle here? And what does that equal? 74. Okay. But on the other triangle, we don't know 2 of the angles. So I think it's a good start that we have 74 on both. We don't know the other 2 angles. So if I know that that's 74, though, what else could I check? The sides. Yeah, so maybe this is side angle side. Okay. So we would match up. What if I start with 14? What would my proportion look like? 14 goes with 13.5. 14 goes with 9, because those are both the smallest side on that triangle. So if I do 14 over 9, what would I have to match that up with? I'm doing big over small right now. What would the other side of this look like? 21 over 13.5. Okay, so we're looking to see, are these two things equal? I don't know off the top of my head if they're equal. What is 14 over 9 as a decimal? You got your calculator out there?
Let's see.
Let's see.
14 is 1.5 repeating.
1.5 repeating. Okay, and 21 divided by 13.5. 1.5 repeating. Okay.
1.5555555.
Okay. So we would say yes. Side angle side. So notice we had kind of a multi-step process here. We had to find the missing angle. But on the other triangle, we had two missing angles, so we couldn't figure out what either one of them were, so we had to pivot and do side angle side.